Today we are going to discuss a question from the ISI JRF mathematics exam. Uh, this question is from the 2021 question paper. This question is particularly from the subject linear algebra. Let's discuss the question first. Given V is a vector space and two of its subspaces V1 and V2 and two elements of the vector space B1 and B2, then we have to show that the affine subspaces, we are defining two subspaces from V1 and V2 by W1 equal to V1 plus B1 and W2 equal to V2 plus B2. These two, W1 and W2, will have a non-empty intersection if and only if the map pi of B1 equal to pi of B2, where pi is a map from V to the quotient space V by V1 plus V2. So we have to prove an if and only if condition here. It's quite easy to prove. So first, in the solution, what we do is we define the map pi. As V is mapped to a quotient space of itself, so we have to map X to a set, not to an element, not to a single element of the V, but to an element of the quotient space, which will be a set. This is something similar to the mappings that we do in or abstract algebra, like we map to cosets. So here we map X to X plus V1 plus V2. So we can suppose pi of B1 equal to pi of B2. Then B1 plus V1 plus V2 should be equal to B2 plus V1 plus V2 by what we have defined before. So from that, it's clear that B1 minus B2 should be an element of V1 plus V2, since B1 minus B2 plus V1 plus V2 equal to V1 plus V2. So B1 minus B2 is an element of V1 plus V2, from which we can conclude that there exists an U1 belongs to V1 and a U2 belongs to V2, such that B1 minus B2 can be written as U1 plus U2. So if we take U1 to the left side and B2 to the right side, then we can write B1 minus U1 equal to U2 plus B2. So they are both equal. So if we call that element Y, then let's analyze B1 minus U1 a little bit. B1 minus U1 is an element of V1, right? So minus U1 will also be in V1, because V1 is a subspace and it is closed under scalar multiplication, and minus 1 is a scalar. So minus U1 will also be in V1, or it's the additive inverse of U1, so it has to be in V1. So minus U1 in V1, and we have selected B1 from where? B1. So if we add an element of V1 to B1, then it's in W1, right? We have defined W1 as V1 plus B1. So minus U1 plus B1 is in W1. So we have got B1 minus U1 in W1. Similarly, U2 is an element of V2, and U2 plus B2 should be in W2. So we have got B1 minus U1 belongs to W1 and U2 plus B2 belongs to W2. But these two are equal. So Y should be an element of W1 and Y should be an element of W2. So Y belongs to W1 intersection W2. That means if pi of B1 equal to pi of B2, then W1 intersection W2 is not empty. The reverse implication is these steps taken in reverse direction. If you take W1 intersection not equal to 5, then there exists a Y as Y belongs to W1 intersection W2. You take the steps in the reverse order. That's why I have given the if and only if implications everywhere on each step. Hope you understand the proof, and hope you have enjoyed the question. If you have any doubts, you can just comment below. Thank you.